you will learn relationship between Ka and Kb. Example: Ka represents the strength of the acid, whereas Kb represents the strength of the base. According to Lowry-Bronsted acids and bases, the acid is a substance which can give a proton in the solution and the base can accept the proton. If the acid dissociates to give a proton, it becomes its conjugate base, and when the base accepts the proton, it becomes its conjugate acid. Ka and Kb of the acid and its conjugate base can be related by a simple equation. Consider the equilibrium reaction of acetic acid. The relationship between Ka and Kb for the respective reactions is depicted in the given equations. Kw value can be calculated from the Ka and Kb values. So, it is seen that for an acid and its conjugate base, the relationship between the acid dissociation constant and its conjugate base dissociation constant is expressed as Ka times Kb is equal to Kw. If we know the acid dissociation constant for the acid, the dissociation constant for its base can be easily calculated from the above expression. It can also be shown by taking the negative logarithm of the above expression. pKa plus pKb equals pKw. You have learnt, according to the Lowry-Bronsted theory of acid and base, when an acid donates its proton, it changes into the conjugate base, and when a base accepts the proton, it becomes its conjugate acid. Ka and Kb are related by a simple equation. The product of acid dissociation constant and the base dissociation constant is equal to the ionic product of water.